Now, in this lecture, we will answer on two questions. The first question is to find out the diameter of this orange circle, and the second question is to find out, we have here a quarter circle and a square ABCO inside this quarter circle, and we want to find out the value of angle theta. So first of all, we will start with the first question. In the first question, we have here three semicircles, and the biggest semicircle consists of two small semicircles and the orange circle, and we want to find out the diameter of this orange circle. We know that the diameter of this small semicircle is equal to 10 units, the diameter of this semicircle is equal to 20 units, and the diameter of the biggest semicircle, it is equal to 10 plus 20 units, that is to say it equals to 30 units, and we want to find out the diameter of the orange circle. First of all, we'll define the centers of the semicircles. We'll define the center of the small semicircle as point X. We will define the center of the biggest semicircle as point Y. And we will define the center of this semicircle as point Z. And the center of this orange circle is at this point, that is actually point C. In the next step, we'll join together all the centers of the semicircles with the center of the orange circle that is located at point C. And in order to find out the length of the line segments that we have in this drawing, I will present to you two new rules. Actually, two circles can be tangent to each other or can touch each other at one point in two different ways. The first type of tangency between two circles, it is actually the external lunge. Those two circles, they are touching each other externally at this point. This is the point of tangency between those two circles, and this is defined as external lunge. We know that the center of the small circle is at point M, and the radius of the small circle is equal to small r, while the center of the big circle is at point O, and the radius of the big circle is defined as capital R, and the distance between the centers of the two circles, that is to say the length of line segment MO, it is equal to the sum of the lengths of their radii. That is to say it will be equal to small r plus capital R. So MO equals to small r plus capital R. Okay, so Actually, whenever two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to small r plus capital R. And we have also another type of tendency between two circles. When the two circles are touching each other internally, like in this drawing, then this is defined as internal length. Those two circles are touching each other internally at this point. This is the point of tendency. So here the distance between the centers of the two circles, that is to say the length of line segment MO, will be equal to capital R minus small r. You can see here that capital R minus small r, it is exactly equal to the length of line segment MO. So whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. Okay, so we'll use those two new rules in order to find out the lengths of the line segments in this drawing. First of all, we will define the center of this orange circle as R, small r. I'll write it down. Small r is defined as the center of the orange circle. So what is the length of CX? What is the length of line segment CX? CX, C is the center of the orange circle, X is the center of the smallest semicircle. Those two circles have an external length between them at this point, that is to say they are touching each other externally at this point, and whenever two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is actually 10 over 2, it is 5 units, plus the radius of this orange circle that we define as small r. So in conclusion, we found out that the length of line segment CX equals to 5 plus r units. Likewise, we will find out the length of line segment CY. I repeat again that C is the center of this orange circle and Y is the center of the biggest semicircle. This semicircle, the orange circle and the biggest semicircle have an internal length between them. At this point, that is to say they are touching each other internally at this point. This is the point of tendency between them, and whenever we have two circles that are touching each other internally, then the distance between their centers, that is to say CY, will be equal to the difference between the lengths of their radii. And the length of the radius of the biggest circle, it is equal to the diameter over 2, that is to say it is equal to 30 over 2, that is 15 units. And the radius of this orange circle is equal to R, so in conclusion, C1 will be equal to 15 minus small r. So we found out that Cy is equal to 15 minus small r. Likewise, we find out the length of line segment CZ. Again, C is the center of the orange circle, Z is the center of this circle that its radius is equal to 20 over 2, it is equal to 10 units. Those two circle and semicircle have an external between them at this point. That is to say they are touching each other externally at this point. And whenever you have two circles that are touching each other externally, then the distance between their centers, that is to say CZ, will be equal to the sum of the lengths of the radii. That is to say it will be equal to the radius of the orange circle, that is small r, plus the radius of this semicircle that is equal to 20 over 2, it is 10. So in conclusion, we found out that the length of line segment CZ, it is equal to r plus 10. Likewise, we will calculate the length of line segment XY. The length of line segment XY is X is the center of this semicircle with radius 5. Y is the center of the biggest semicircle with radius that's equal to 15 units. The smallest semicircle and the biggest semicircle are touching each other internally at this point, point A, therefore the distance between their centers will be equal to the difference between the lengths of the radii. The radius of the biggest circle is 15 units. The radius of the smallest semicircle is 5 units. And the difference between those two radii is 15 minus 5, that is 10 units. So we actually found out that the length of line segment XY it is equal to 10 units. And we will also calculate the length of line segment XZ. Here XZ, I'll repeat again that X is the center of the smallest semicircle, Z is the center of this semicircle. Those two semicircles have an external notch between them at this point, point P. That is to say they are touching each other at point P externally, and therefore the distance between their centers will be equal to the sum of the lengths of the radii. That is to say it will be equal to the radius of this semicircle, that is 5, plus the radius of this semicircle, that is 10. In conclusion, xz equals to 5 plus 10, that is 15. Okay, so we found out that xz equals to 15 units. So we actually found out all the lengths of all the line segments here. In the drawing, in the next step, I will present to you a new law. That is actually the law of cosines. The law of cosines is true for any triangle. So we have here triangle ABC, that could be any triangle. This is triangle ABC. And this is the law of cosines. we know that the length of side AB of triangle ABC is equal to A units, the length of side BC of triangle ABC equals to B units, and the length of side AC of triangle ABC is equal to C units, and we also know that the angle between side AB and side BC of triangle ABC is equal to theta. Then according to the law of cosines, we will get that C squared is equal to A squared plus B squared minus 2 times A times B times cosine theta. And this equation is true for any triangle. Actually, the Pythagoras theorem is a special case of the law of cosines when theta is equal to 90 degrees. Why? Because if theta equals to 90 degrees, then cosine theta will be equal to 0. So this expression 2ab cosine theta will be equal to 0. Because anything multiplied by 0 is 0. And we'll get that C squared equals to A squared plus B squared, and that is exactly the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, I'll repeat again that the Pythagoras theorem is a special case of the law of cosines when theta is equal to 90 degrees. And we are talking about a right triangle. So, now we will implement the law of cosines in our triangle CXY. So I will copy triangle CXY in a new page, and we will implement the law of cosines in triangle XCY. So this is triangle CXY that I copied from the original drawing. We know that this angle equals to theta. We have already found out that the length of line segment CX is equal to 5 plus R. And we have already found out that xy equals to 10 units, and the cy, it is equal to 15 minus r units. Now we can implement the law of cosines in triangle CXY. According to the law of cosines, this will be equation number 1. Cy squared is equal to Cx squared plus xy squared minus 2 times Cx xy cosine theta. We know the values of cy, cx and xy, so we'll substitute those variables by the values that we found for them, and we will get that according to equation number 1, cy is equal to 15 minus r, so cy squared will be equal to 15 minus r squared, and it is equal to cx squared. Cx is 5 plus r, so cx squared will be equal to 5 plus r squared plus xy. Xy is equal to 10, so xy squared will be equal to 10 squared, that is 100, minus 2 times Cx is 5 plus r times xy, that is 10 times cosine theta. Here we will open the brackets on both sides of this equation number 1, and we get that 15 minus r squared equals to 15 squared, that is 225, plus r squared, minus 2 times 15 times r, this is minus 30r, that is equal to 5 plus r squared. 5 plus r squared equals to 5 squared, that is 25, plus r squared, plus 2 times 5 times r, it is 10 times r, plus 100, minus 2 times 10 is minus 20, times 5 plus r times cosine theta. So here we have r squared on both sides of equation number 1, so r squared will get cancelled. So we have here 225 minus 30r, that is equal to 100 plus 25 is 125, plus 10r minus 20 times 5 plus r times cosine theta. Here we subtract 125 and also 10r from this equation number 1, and we will get that 225 minus 125 is 100, minus 40r minus 10r is minus 40r, and it is equal to minus 20 times 5 plus r times cosine theta. Here we will multiply equation number 1 by minus 1, and we'll get that 40r minus 100 equals to 20 times 5 plus r times cosine theta. So here we will divide equation number 1 by 20 times 5 plus r, and we get that according to equation number 1, we found out that cosine theta is equals to 40r minus 100 over 20 times 5 plus r. So here we will divide both the numerator and the denominator of this side of equation number 1 by 20, and we will get that 40 over 20 is 2r, minus 100 over 20 is minus 5, 20 over 20 is 1, so here we will have 5 plus r. So actually we found out that according to equation number 1, cosine theta is equal to 2r minus 5 over 5 plus r. In the next step, we will implement the law of cosines in triangle CXZ So I'll copy triangle CXZ in this new page and we will implement the law of cosines in this triangle, triangle CXZ. So this is triangle CXZ that they copied from the original drawing. We've already found out that CX, side CX equals to 5 plus R. We have already found out that XZ is equal to 15 units, and we have already found out that CZ is equal to R plus 10 units. Now we can implement the law of cosines in this triangle, triangle CXZ. This will be equation number 2. According to the law of cosines, we will get that CZ squared equals to CX squared plus XZ squared minus 2 times CX times XZ times cosine theta So we know the values of CZ, CX and XZ, so we'll substitute CZ, CX and XZ by the values that we found for them, and we'll get that according to equation number 2. CZ is R plus 10, so CZ square will be equal to R plus 10 squared. And it is equal to Cx, that is actually 5 plus R, so Cx squared will be equal to 5 plus R squared, plus xz squared. Xz is equal to 15, so xz squared will be equal to 15 squared, that is 225, minus 2 times Cx is 5 plus R, xz is 15 times cosine theta. So R plus 10 squared, it is equal to R squared plus 10 squared, that is 100, plus 2 times R times 10, that is 20R, and it is equal to 5 plus R squared. 5 plus R squared equals to 5 squared, that is 25, plus R squared, plus 2 times 5R is 10 times R, plus 225 minus 2 times minus 15 is minus 30 times 5 plus R times cosine theta. Here in equation number 2 we have R squared on both sides of the equation, so R squared will get cancelled. So what is left after we cancel R squared from equation number 2, we have in this side of equation number 2 100 plus 20R, that is equal to 225 plus 25 is 250 plus 10R minus 30 times 5 plus r times cosine theta. Here we'll subtract 250 from this equation, and we'll also subtract 10 from this equation. So here we'll get that 100 minus 250 is minus 150. 20r minus 10r is 10r. And it is equal to minus 30 times 5 plus r times cosine theta. Here we will multiply equation number 2 by minus 1, and we get that according to equation number 2, $150 minus 10r, it is equal to 30 times 5 plus r times cosine theta. Here we'll divide equation number 2 by 30 times 5 plus r, and we'll get that according to equation number 2, cosine theta is equal to 150 minus 10r over 30 times 5 plus r. Here we'll divide both the numerator and the denominator on this side of equation number 2 by 10, and we get that 150 over 10 is 15, minus 10r over 10 is minus r, 30 over 10 is 3. So in conclusion, we found out that cosine theta, according to equation number 2, it is equal to 15 minus r over 3 times 5 plus r. But according to equation number 1, we have already found out that cosine theta, it is equal to 2r minus 5 over 5 plus r. In the next step, we will create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So equation number 3 states that cosine theta according to equation number 1, that is 2r minus 5 over 5 plus r, it must be equal to cosine theta according to equation number 2, that is 15 minus r over 3 times 5 plus r. Here we will multiply equation number 3 by 5 plus r. So here 5 plus r will get cancelled. In the next step, we will multiply equation number 3 by 3, and we will get that according to equation number 3, 3 times 2r minus 5 is equal to 15 minus r. Here we'll open the brackets, equation number 3, and we'll get that 3 times 2r is 6r, 3 times minus 5 is minus 15, and it is equal to 15 minus r. Here we'll add the equation number 3r, and we'll add also 15, and we get that according to equation number 3, 6r plus r is 7r, and here 15 plus 15 is 30. So in conclusion, we found out that according to equation number 3, 7r equals to 30. We divide the equation number 3 by 7, and we get that the radius of the semicircle is equal to 30 over 7 units. We found the radius, but we want to find out the diameter of the orange circle. The diameter is twice as large as the radius, so the diameter of the orange circle will be equal to 2r, that is to say it will be equal to 2 times the radius, that is 30 over 7. So in conclusion, we found out that the diameter of the orange circle, it is equal to 60 over 7 units. So in terms of numbers, it equals to 8.5714 units. I'll repeat again. The diameter of the orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Okay? So in the next step, I will summarize the lecture. Actually, we wanted to find out the diameter of this orange circle. We have in the drawing 3 semicircles, and inside the biggest semicircle we have 2 small semicircles and 1 orange circle. And we want to find out the radius of this orange, the diameter of this orange circle. So first of all, we know that the center of this orange circle is at point C. We define the center of this semicircle as X. We define the second. We define the center of the biggest semicircle, this semicircle as Y, and we define the center of this semicircle as point Z. Then we join together point C with all the centers of the other semicircles, and in order to find out the lengths of all the line segments that we have here, I presented to you 2 new rules. Actually, 2 circles can touch each other in 2 different ways. The first type of tangency is the external tangency. That is actually the external lunge. Those 2 circles are touching each other externally at this point. This is the point of tangency between those 2 circles. And the distance between 2 circles that have an external lunge between them, like in this drawing, it will be equal to the sum of the length of the radii. In this case, it will be equal to capital R plus small r. So the length of line segment MO, that is to say the distance between the centers of the two circles, will be equal to capital R plus R. And we have also a second type of tendency. The second type of tendency is when the circles are touching each other internally. In this case, they are touching each other internally at this point. This is the point of tendency. And in this case, the distance between the centers, when there is an internal length between the two circles, will be equal to the difference between the lengths of the radii. In this case, it will be equal to capital R minus small r. So we implemented those two rules in our drawing. Here we found out the size or the length of line segment CX. C is the center of the orange circle, and X is the center of the semicircle with radius 5. Those two circles have an external length between them. At this point, therefore, the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, Cx will be equal to 5 plus r. Likewise, we calculated the value of line segment Cy. Again, C is the center of the orange circle. Y is the center of the biggest semicircle. Those two circles in the semicircle have an external length between, an internal length between them at this point. That is to say, they are touching each other internally at this point. This is the point of tendency between the circle and the semicircle. And whenever there is an internal length between two circles, then the distance between their centers will be equal to the sum, to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest circle, that is 15 units, minus the radius of this orange circle, that is r. That is to say, Cy equals to 15 minus r. Likewise, we calculated the value of line segment CZ. C is the center of the orange circle, Z is the center of this semicircle. Those two circles and semicircle have an external length between them at this point. That is to say, they are touching each other externally at this point. Whenever we have an external length between them, then the distance between the centers of the two circles will be equal to the sum of the lengths of their radii. That is to say, Cz will be equal to small r plus 10. Okay, then we calculated the length of line segment xy. Actually, y is the center of the biggest circle, x is the center of the smallest circle, and the biggest semicircle and the biggest semicircle and the smallest semicircle have an internal length between them at this point, point A. And whenever you have two circles with an internal length between them, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest circle, that is 15, minus the radius of this smallest semicircle, that is 5. That is to say, xy equals to 15 minus 5. That is to say, it is equal to 10 units. So xy equals to 10 units. Then we found out the value of line segment xy. Here, so xy is equal to 10 units, and we found out the value of line segment xz. X is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two circles have an external length between them at point P, and whenever we have two circles with an external length between them, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to the radius of this semicircle, that is 5 units, plus the radius of this semicircle, that is 10 units. In conclusion, this is equal to 5 plus 10, that is 15. So we found out that C xz equals to 15 units. Then I presented to you a new law, that is the law of sines, the law of cosines. Here, the law of cosines. The law of cosines is true in any triangle. So here, if we have triangle ABC, that could be any triangle. We know that side AB of the triangle is equal to A units, side BC of the triangle equals to B units, and side AC is equal to C units. And we also know that the angle between side AB and side BC is theta. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine theta. And the Pythagoras theorem is a special case of the law of cosines when cosine theta, when theta equals to 90 degrees, then cosine theta is 0. So this expression 2AB cosine theta is 0. And we will get the Pythagoras theorem that C squared equals to A squared plus B squared, that is to say the square of the hypotenuse equals to the sum of the squares of the perpendicular. So I repeat again that the Pythagoras theorem is a special case of this law, the law of cosines, when theta is equal to 90 degrees. And then we are talking on right triangle. So we implemented the law of cosines on triangle CXY. So I copied triangle CXY in a new page, and we implemented the law of cosines in this triangle CXY. We already found out that Cx equals to 5 plus r, xy equals to 10, and cy equals to 15 minus r. So according to the law of cosines, we get that Cx squared equals to xy squared plus cy squared times minus 2 times xy times cy times cosine theta. Then we substituted Cx, cy, and xy by the values that we found for them, and we got that cy is 15 minus r, so cy squared is 15 minus r squared, and it is equal to cx squared. Cx is 5 plus r, so cx squared is 5 plus r squared, and plus xy is 10, so xy squared will be equal to 10 squared, that is 100, minus 2 times AB times cosine theta. It is actually minus 2 times xy times 2 times minus 2 times cx times xy times cosine theta. Cx is 5 plus r, xy is 10, so we got this expression. We open the brackets on both sides of equation number 1, and we got that 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15 times r is minus 30r, and it is equal to 5 plus r squared. 5 plus r squared equals to 5 squared, that is 25, plus r squared minus it is plus 2 times 5r is 10r, plus 10r plus 100 minus 2 times 10 is minus 20 times 5 plus x times cosine theta. So in this side of the equation, we have r squared on both sides of the equation, so r squared will get cancelled. And in this side of the equation, we have 225 minus 30r, that is equal to 25 plus 100 is 125. And we also have here 10r minus 20 times cosine 5 minus r times cosine theta. Okay, then we subtracted from this equation 125, so 225 minus 125 is 100. We subtracted also 10 out from this equation, and we got that minus 40r minus 10r is minus 40r. So in this side of the equation we have 100 plus 40r, that is equal to minus 20 times 5 plus r times cosine theta. We multiply the equation number 1 by minus 1, and we got that 40r minus 100 equals to 20 times 5 plus r over cosine theta. We divided the equation number 1 by 20 times r plus 5, and we got that according to equation number 1, cosine theta equals to 40r minus 100 over 20 times 5 plus r. We divided both the numerator and the denominator of this equation by 20, and we got that 40r over 20 is 2r, and minus 100 over 20 is minus 5, and it is equal to 20 over 20 is 5 plus r. So in conclusion, we found out that cosine theta is equal to 2r minus 5 over 5 plus r. And repeat again, according to equation number 1, we found out that cosine theta is equal to 2r minus 5 over 5 plus r. Then I copied triangle CXZ in this page, and we implemented the law of cosines in this triangle CXZ. We already know that Cx equals to 5 plus r, xz is equal to 15 units, and Cz is equal to r plus 10. And according to the law of cosines, we get that Cz square equals to Cx square plus xz square minus 2 times Cx times xz. Okay, and so we got that Cz square equals to Cz square equals to Cx square plus xz square minus 2 times Cx times xz times cosine theta. Then we put the values of Cx, xz and cz inside this equation, and we found out that r plus 10 squared equals to 5 plus r squared plus 225 minus 2 times 5 plus r times 15 times cosine theta. We open the brackets here, and we got that r plus 10 squared equals to r squared plus 10 squared is 100 minus plus 2 times 10r is actually 20r, and then 5 plus r squared equals to 5 squared, that is 25, plus r squared plus 2 times 5r is 10r, and the minus 2 times minus 15 is minus 30 times 5 plus r times cosine theta. Here we have r squared on both sides of the equation, so r squared will get cancelled. And what is left after we cancel r squared? What is left in this side of the equation, number 2, we have 100 plus 20r, and on the other side we have 25 plus 225 is 250, and we also have 10r minus 15 times 2 is minus 30 times 5 plus r times cosine theta. Okay, so here we subtracted 250 from this equation, and we subtracted also 10r from this equation, and we got that 100 minus 250 is minus 150, 20r minus 10r is 10r, and it is equal to 30 times 5 plus r times cosine theta. We multiply the equation number 2 by minus 1, and we got that 150 minus 10r equals to 50 times 5 plus r times cosine theta. Here we divided the equation number 2 by 30 times 5 plus r. We got that according to equation number 2, cosine theta equals to 150 minus 10r over 30 times 5 plus r. We divided both the numerator and the denominator of this side of the equation by 10, and we got that 150 over 10 is 15, minus 10 over 10 is minus r, 30 over 10 is 3. So in conclusion, we found out that according to equation number 2, cosine theta equals to 15 minus r over 3 times 5 plus r. Okay, then actually we found out that cosine theta according to equation number 2 is equal to 15 minus r over 3 times 5 plus r. This is according to equation number 2, but according to equation number 1, we have already found out that cosine theta equals to 2r minus 5 over 5 plus r. Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So, according to equation number 3, cosine theta according to equation number 1 is 2r minus 5 over 5 plus r, and cosine theta according to equation number 2 is 15 minus r over 3 times 5 plus r. So those two expressions must be equal to each other because both of them are cosine theta. We multiplied this equation number 3 by 5 plus r, so 5 plus r will get cancelled from the denominator, and we left only actually we multiplied this equation by 3, and we got that 3 times 2r minus 5 is equal to 15 minus r. We opened the brackets here, and we got that 3 times 2r is 6r, 3 times minus 5 is minus 15, and it is equal to 15 minus r. We added r to this equation, and we also added 15 to this equation. We got that 6r plus r is 7r, and 15 plus 15 is 30. We divided equation number 3 by 4. We divided equation number 3 by 7, and we got that r equals to the radius of the orange circle equals to 30 over 7 units, but we want to find the diameter that is twice as large as the radius. So the diameter of the orange circle will be equal to 2 times the radius, and the radius is 30 over 7, so it will be equal to 2 times 30 over 7 units. So in conclusion, we found out that the diameter of the orange circle is equal to either 60 over 7 units, or in terms of numbers, the diameter of the orange circle equals to 8.5714 units. I repeat again, the diameter of the orange circle will be equal to either 60 over 7 units, or in terms of numbers, it is equal to or in terms of numbers, it is equal to 8.5714 units. We finish with this question. In the next step, I will present to you the solution to the second question. In the drawing, we have a quarter circle, and inside this quarter circle we have square ABCO. We know that this angle A and B is equal to 90 degrees. This angle BQC is equal to theta, and we want to find out the side of angle theta. So in order to find out the value of angle theta, we will make a construction. We will extend line segment MA by a straight line, and we will also extend line segment QO by a straight line until they intersect with each other. And we will define the intersection point between extended line segment MA and extended line segment QO as point N. And we will also complete the quarter circle to a semicircle. So we created here a semicircle, and inside this semicircle we have peripheral angle NMQ. It is a peripheral angle that is equal to 90 degrees. And we have rule number 1 that is related to a peripheral angle that are equal to 90 degrees according to rule number 1. Any peripheral angle that is equal to 90 degrees, that it is equal to 90 degrees must rest on the diameter. We read rule number 1 again. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So here we have the peripheral angle NMQ that is equal to 90 degrees, and according to rule number 1, this peripheral angle that is equal to 90 degrees must rest on the diameter. So this right angle rests on NQ. Therefore, according to rule number 1, NQ is the diameter of the semicircle. Okay, according to rule number 1, line segment NQ is the diameter of the semicircle. Actually, we have here a quarter circle. In this quarter circle, QO must be the radius of the quarter circle. So we define the radius of the quarter circle QO as capital R. And actually O must be also the center of the quarter circle and the center of the semicircle. And we also note that the diameter of any circle is twice as large as the radius, so if the radius of this semicircle is equal to capital R, then the diameter NQ will be twice as large as the radius, that is to say NQ will be equal to 2 times capital R. Okay? And here actually NO from the drawing, it is very easy to see that line segment NO will be equal to NO equals to NQ minus QO. NQ minus OQ. I'll repeat again. Line segment NO equals to NQ minus OQ. So NO is equal to NQ, that is 2 times capital R, minus QO, that is capital R, 2 times capital R minus 1 times capital R, it is capital R, so we found out that NO is equal to capital R, that is the radius of the semicircle and also the radius of the quarter circle. So we can write here that NO it is equal to capital R, and we will focus on the right triangle NMQ. In this right triangle we have one angle that is equal to 90 degrees, one angle that is equal to theta. We'll define this angle as angle X. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So I'll write it down. In the right triangle NMQ, the sum of its three angles must be equal to 180 degrees. That is to say angle X plus this angle that is angle theta plus this angle that is 90 degrees. In total, the sum of those three angles must be equal to 180 degrees. Okay, I'll repeat again. The sum of the angles in the right triangle NQ must be equal to 180 degrees. We'll subtract 90 degrees from this equation, and we'll get that X plus theta equals to 180 degrees minus 90 degrees, it is 90 degrees. We'll subtract theta from this equation, and we'll get that angle X is equal to 90 degrees minus theta. Okay, we found out that angle X equals to 90 degrees minus theta, so we can write here that angle X is equal to 90 degrees minus theta, so we'll substitute angle X like 90 degrees minus theta. We know that all the angles inside the square are right angles. Therefore, inside square ABC, we have 4 right angles. So we'll draw here inside square ABCO 4 right angles. All those angles are right angles, they are equal to 90 degrees. Just draw in any square. Because of the fact that MQ is the diameter of the semicircle, NQ is absolutely a straight line. So you can write down that line segment NQ is a straight line. Line segment NQ is a straight line. And we also have rule number 2 that is related to straight lines. According to rule number 2, the sum of the angles on one side of a straight line the sum of the angles on one side of a straight line is equal to 180 degrees. So I'll read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. And we know that NQ is a straight line. So if we focus on the upper side of the straight line NQ at point O, then the sum of the angles must be equal to 180 degrees on the upper side of NQ at point O. So which angles we have at point O on the upper side of NQ? We have here 90 degrees. We also have here angle AON. So the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. We know that NQ is a straight line, so if you focus on the upper side of the straight line NQ at point O, then the sum of the angles on the upper side of NQ at point O must be equal to 180 degrees according to rule number 2. So at point O we have two angles, 90 degrees, and the angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation, and we will get that angle AON is equal to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that angle AON is a right angle. It is equal to 90 degrees. This angle is a right angle. Likewise, if we focus on the upper side of the straight line AQ at point C, then the sum of the angles on the upper side of the NQ of NQ at point C, the sum of the angles must be equal to 180 degrees. Which angles we have at point C? On the upper side of NQ, we have here one angle that is a right angle, plus this angle that is actually angle BCQ. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 2. I'll repeat again. On the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees according to rule number 2. We have two angles at point C. On the upper side of NQ, we have 90 degrees plus angle BCQ. And in total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation, and we get that angle BCQ is equal to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that angle BCQ is equal to 90 degrees. Angle BCQ is equal to 90 degrees. So we will continue to focus on the right triangle BCQ. In the right triangle BCQ, the sum of the angles must be equal to 180 degrees. So if we define this angle as angle Y, then angle Y plus this angle that is equal to 90 degrees plus this angle that is theta, in total the sum of those three angles must be equal to 180 degrees. We'll subtract 90 degrees from this equation, and we'll get that Y plus theta equals to 180 degrees minus 90 degrees. It is 90 degrees. We'll subtract theta from this equation, and we get that angle Y equals to 90 degrees minus theta. So we found out that angle Y equals to 90 degrees minus theta. We substitute angle Y by 90 degrees minus theta. We will focus on the right triangle AON. In the right triangle AON, the sum of the angles must be equal also to 180 degrees. We will define the missing angle in the right triangle AON. This angle is angle X, and angle X plus 90 degrees, this angle that is 90 degrees, plus this angle that is 90 degrees, minus theta. In total, the sum of those three angles must be equal to 180 degrees. I'll repeat again. In the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. Here we have 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we have angle X minus theta is equal to 0. After we cancel 180 degrees, we got that X minus theta equals to 0. We will add theta to this equation, and we'll get that angle X is equal to theta. So we found out that angle X is equal to theta, so we'll substitute angle X by theta. So we actually found out that all three angles of the right triangle, triangle AON, are equal to all the three angles in the right triangle, triangle BCQ. Here, both angles are equal to theta. Both those two angles are equal to 90 degrees minus theta, and both those two angles are equal to 90 degrees. Therefore, we can derive from it that the right triangle, triangle AON is similar to the right triangle, triangle BCQ, I'll repeat again. We will derive from the fact that triangle BCQ is similar to triangle AON. We will derive from the fact that all the angles of triangle BCQ are equal to all the angles of triangle AON, that triangle AON is similar to triangle BCQ. This is the sign of similar, and they are similar to each other according to angle similarity rule. I'll repeat again. Triangle AON is similar to triangle BCQ according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that CQ over AO is equal to BC over NO. I'll repeat again, according to question number 1, because of the fact that triangle AON is similar to triangle BCQ, we derive that CQ over AO equals to BC over ON. And what is the value of CQ? Here, the value of line segment CQ. CQ is equal to OQ minus OC. I'll repeat again. CQ equals to OQ minus OC. So actually CQ is equal to OQ, that is capital R, it is the radius of the semicircle, minus OC. We will define OC as A. So if one side of square ABCO equals to A, then all the other side will be also equal to A because of the fact that all the sides of a square are equal to each other. So in conclusion, we found out that CQ equals to R minus A, and we can substitute Q by R minus A in equation number 1, this equation, so we'll get that CQ that is equal to R minus A over AO. AO is equal to A. It is equal to BC, that is also A, over NO. We already found out that NO equals to capital R, it is the radius of the semicircle. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. Here we will divide this expression to two parts, and we will get that according to equation number 1, R over A minus A over A minus A over A is minus 1. It is equal to A over R. So according to equation number 1, R over A minus 1 equals to A over R. We will focus on the right triangle AON, this right triangle. In the right triangle AON, tangent theta is equal to R over A. Here, tangent theta equals to R over A. Therefore, we can substitute R over A in equation number 1 by tangent theta. We'll do it now and we'll get that according to equation number 1, R over A is tangent theta. Minus 1 equals to A over R, but A over R is 1 over R over A. And we know that R over A is equal to tangent theta, so we can substitute R over A in this equation number 1 by tangent theta. We'll do it now and we'll get that according to equation number 1, tangent theta minus 1 equals to 1 over tangent theta, because R over A is tangent theta, so we substituted R over A by tangent theta. Here we will multiply this equation number 1 by tangent theta, and we'll get that according to equation number 1, tangent theta times tangent theta is tangent squared theta. Minus 1 times tangent theta is minus tangent theta, and it equals to 1. Here we'll subtract 1 from this equation, and we get that according to equation number 1, tangent squared theta minus tangent theta minus 1 is equal to 0. So here we got the quadratic equation, and the missing variable of this quadratic equation is tangent theta. Actually, the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general quadratic equation, A, B, C are the coefficients of the quadratic equation. A, B, and C are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to a special formula for x. X is equal to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay? In our specific quadratic equation, here the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is also equal to minus 1. And the variable that we are looking for is tangent theta, so x equals to tangent theta. So we will put the data in the equation for x in order to find out the value of the values of tangent theta. So here x is tangent theta, so tangent theta equals to minus b. B is equal to minus 1, so minus b is minus 1, minus 1 is plus 1, plus minus square root of b squared. B squared is minus 1 squared, that is 1, minus 4 times a is 1, times c is minus 1 over 2a, a is 1, so it is 2 times 1, that is 2. So here we found out that tangent theta is equal to 1 plus minus square root of minus 1 times minus 4 is 4, 4 plus 1 is 5 over 2. So here we will have two solutions that are possible for tangent theta. The first solution is tangent theta is equal to 1 plus square root of 5 over 2. This is the positive solution. And the second solution for tangent theta is that tangent theta is equal to 1 minus square root of 5 over 2. That is actually a negative solution, it is less than 0. But here, if you focus on the right triangle, triangle NMQ, this angle is equal to 90 degrees minus theta. So this angle that is equal to 90 degrees minus theta, it is 1 out of 3 angles of the right triangle, triangle NMQ. Therefore, it must be a positive number. So we can write down that angle 90 degrees minus theta is a positive, it is greater than 0. We will add theta to this equation and we will get that theta is less than 90 degrees from one side, but from the other side you can see here that this is angle theta, the angle that we are looking for, and this angle theta, it is absolutely a positive number, so angle theta is greater than 0. So we actually found out that angle theta is greater than 0 and less than 90 degrees. And actually in this range, when theta is greater than 0 and less than 90 degrees, then the function tangents or tangent theta will be a positive number. will be greater than 0. But according to the second solution, we found out that tangent theta is a negative number. We found here that tangent theta is less than 0. It is a negative number. So we have here a contradiction. Therefore, this solution is incorrect solution. So we will cancel this solution. And we will left only with the solution that tangent theta is equal to 1 plus square root of 5 over 2 okay. Tangent theta is equal to 1 plus square root of 5 over 2. We want to find out the value of theta itself. So we will have to operate the opposite function of tangents on the result that is 1 plus square root of 5 over 2. So we'll operate the opposite function of tangents, that is inverse tangents, on the result that is 1 plus square root of 5 over 2 in order to find out the value of theta itself, and we'll find out that the inverse function of tangents on 1 plus square root of 5 over 2 will give us that theta itself equals to 58.28 degrees. So we found out that angle theta, the angle that we are looking for, it is equal to 58.28 degrees. And that is the answer to the question. This is the missing angle. Angle theta equals to 58.28 degrees. Now I will summarize the lecture. Actually, we wanted to find out the size of this angle, angle theta. We have here a quarter of a circle. Inside this quarter circle we have square ABCO, and inside the quarter circle we have also this angle AMB that is equal to 90 degrees, a right angle, and we have also this angle BQC that is equal to theta, and we want to find out the size of angle theta. In order to find out the size of angle theta, we made a construction. We extended MA by a straight line, and also we extended QO by a straight line until they intersect with each other at this point. Point N is the intersection point between the extended MA and the extended line segment QO. And then we also completed the quarter circle to a semicircle, and we got here the peripheral angle NMQ, that is a right angle. And we have rule number 1 that is related to peripheral angle that is a right angle. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. Because of the fact that the peripheral angle NMQ is equal to 90 degrees, therefore according to rule number 1, it must rest on the diameter, and peripheral angle NMQ rests on NQ. That is to say, line segment NQ is the diameter of the semicircle. According to rule number 1, we will conclude that NQ is the diameter of the semicircle. And in this quarter circle, QO must be the radius of the quarter circle, that is to say it will be equal to capital R. According to our definition, the radius of this circle and semicircle is equal to capital R. O is the center of the semicircle and quarter circle. And here we know that the diameter of any circle is twice as large as the radius, so therefore, if the radius is equal to capital R, then the diameter Qn will be equal to 2R. So the diameter NQ equals to 2R. And what is the value of ON? For the domain, it is very easy to see that ON equals to QN minus QO. Okay, ON equals to ON minus QO. It is equal to NQ minus OQ. NQ minus QO, it is equal to NO. NQ equals to 2R, QO equals to R, so we found out that NO equals to 2R minus R, that is R. So NO equals to R, OQ equals to R, and NQ equals to 2R. And in the right triangle NMQ, the sum of the angles must be equal to 180 degrees. So here, in this right triangle we have 90 degrees plus angle theta plus the missing angle that will define this angle x. In total, the sum of those two angles in the right triangle, triangle N and Q, must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that x plus theta equals to 90 degrees. We subtracted theta from this equation, and we got that angle x, the missing angle, it is equal to 90 degrees minus theta. So we found out that this angle equals to 90 degrees minus theta. Then actually, because of the fact that NQ is the diameter of the semicircle, it is absolutely a straight line. So we can write down that NQ is a straight line. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So here, first of all, we know that all the sides, all the angles inside the square are right angles, so all the angles inside square ABCO are equal to 90 degrees. And we also know that NQ is a straight line. So if we focus on the upper side of NQ on point O, then the sum of the angles here must be equal to 180 degrees. So which angles we have in point O? We have here 90 degrees, and we have also angle AON. And according to rule number 2, this rule, 90 degrees plus the size of angle AON, in total they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we found out that this angle AON, it is a right angle. Okay? Likewise, we know that NQ is a straight line, so if you focus on the upper side of the straight line NQ at point C, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have here 90 degrees plus angle BCQ, and the sum of those two angles in total must be equal to 180 degrees. 90 degrees plus the size of angle BCQ, in total they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we found out that angle BCQ, this angle, it is a right angle. Okay, then we continue to focus on the right triangle, triangle BCQ. On the right triangle, triangle BCQ, the sum of the angles must be equal to 180 degrees. So we defined the missing angle as angle Y. Angle Y plus 90 degrees plus angle theta. In total, they must be equal to 180 degrees. Angle Y plus 90 degrees plus angle theta. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that angle Y plus angle theta equals to 180 degrees minus 90 degrees. It is 90 degrees. We subtracted theta from this equation, and we got that angle Y equals to 90 degrees minus theta. Okay, angle Y equals to 90 degrees minus theta. Then we focus on the right triangle, triangle AON. On the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. So this is the missing angle that we define as angle X. This is 90 degrees, and this angle equals to 90 degrees minus theta. So in total the sum of the three angles, that is angle x plus 90 degrees plus 90 degrees minus theta, they must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on this side of the equation and we have 180 degrees on the other side of the equation, so 180 degrees will get cancelled and we left only with x minus theta, that is equal to 0. We added theta to this equation and we got that angle x equals to theta. Here angle x is equal to theta, this angle equals to theta, so we substitute the x by theta. So we actually found out that all the angles of the right triangle AON are equal to all the angles of the right triangle BCQ. Both triangles have angle theta, both those two triangles have angle that is 90 degrees minus theta, and both those two triangles have angle that is equal to 90 degrees. Therefore, those two triangles, all the angles of one triangle are corresponding equal to all the angles of another triangle. Therefore, we actually can conclude from it that the right triangle, triangle AON, is similar to the right triangle, triangle BCQ. And because of the fact that those two triangles are similar to each other, they are similar to each other according to angle similarity rule. And because of the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between their sides. That is to say, we will conclude that CQ over AO, it is equal to BC over ON. CQ over AO equals to BC over NO. Okay, what is the value of CQ? Line segment CQ will be equal to OQ minus OC. CQ equals to OQ minus OC. OQ is equal to capital R. OC is equal to A according to our definition. So in conclusion, we found out that CQ equals to capital R minus A. So we can substitute CQ in equation number 1, this equation by capital R minus A. We did it and we got that according to equation number 1, CQ is R minus A and OA is also A and it must be equal to BC. BC is also A over ON and ON is capital R. So in conclusion, according to equation number 1, we found out that R minus A over A equals to A over R. Okay. We divided the expression R minus A over A to two parts. It is equal to R minus A. It is R minus A over A equals to R over A minus A over A, that is minus 1. So R minus A over A equals to R over A minus 1, that is equal to R A over R according to equation number 1. We focused on the right triangle, triangle AON. In this right triangle, triangle theta equals to R over A. In the right triangle, triangle AON, triangle theta equals to R over A. Therefore, we can substitute R over A in equation number 1 by triangle theta. We did it and we got that according to equation number 1, R over A is triangle theta minus 1 equals to A over R, but A over R is 1 over R over A, so we can substitute R over A by tangens theta. We did it and we got that according to equation number 1, tangens theta minus 1 equals to 1 over R over A, that is tangens theta. So in conclusion, we found out that tangens theta minus 1 equals to 1 over tangens theta. We multiplied the equation number 1 by tangens theta, and we got that tangens theta times tangens theta is tangens square theta. And minus 1 times tangens theta is minus tangens theta, and it is equal to 1. We subtracted 1 from equation number 1, and we got the tangens theta, tangens square theta minus tangens theta minus 1 equals to 0. So we have here a quadratic equation, and the missing variable in this quadratic equation is tangens theta, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 1, and the coefficient c equals to also minus 1, and x is equal to tangent theta. So we will put the data inside the equation for x in order to find out the value of the values of tangent theta. So according to the special formula for x, we will get that x that equals to tangent theta equals to minus b. B is equal to minus 1. So minus b is minus minus 1, minus 1 is plus 1. So it is plus 1 plus minus square root of b squared. B is minus 1, so b squared is minus 1 squared, minus 1 squared is 1, minus 4 times a is 1, times c is minus 1. So minus 4 times minus 1 is 4, and 4 plus 1 is 5. So in conclusion, we found out that tangent theta equals to 1 plus minus square root of 5 over 2. So here we will have two solutions that are possible for tangent theta. The first solution is the positive solution, that is tangent theta equals to 1 plus square root of 5 over 2. And the second solution is a negative solution, that tangent theta equals to 1 minus square root of 5 over 2 is a negative. But here in the right triangle, triangle NMQ, we have this angle that is 90 degrees minus theta. So this angle is one out of 3 angles inside a right triangle. Therefore, it is absolutely a positive number. So we can write down that 90 degrees minus theta, it is positive, it is greater than 0. We added theta to this inequality, and we got that 90 degrees minus theta is smaller than 90 degrees, but theta actually it is absolutely a positive angle. Theta is a positive number, therefore it is a positive angle, it is greater than 0. You can see here from the drawing. So in conclusion, we found out that theta from one side is greater than 0, but from the other side is less than 90 degrees. And in this range of angles, the function tangents itself, tangents theta, it is a positive. When theta is between 0 to 90 degrees, tangents, the function tangents is a positive, but according to the second solution, tangents theta is a negative number. But tangents theta must be a positive number, according to what we have just right now found out. So we have here a contradiction, so this solution is incorrect solution. We cancel this solution, and we left only with the solution that tangents theta equals to 1 plus square root of 5 over 2. So if tangents theta equals to 1 plus square root of 5 over 2, then what is the value of theta itself? In order to find out the value of theta itself, we must operate the opposite function on the result. That is to say, we must operate the opposite function of tangents, that is inverse tangents, on the result that is 1 plus square root of 5 over 2, in order to find out the value of the angle itself, the value of angle theta itself. So we operated the inverse function of tangents on the result that is 1 plus square root of 5 over 2, and we found out that angle theta itself equals to 58.28 degrees. I'll repeat again, the value of this missing angle that we are looking for, theta, it is equal to 58.28 degrees. Okay? Thank you very much.